Saxon Advanced Mathematics. This is a video for Laura and for Vivian on problem 17 from lesson 31. It says, find the domain of the function f of x equals. I'm just going to write it down and then I'm going to talk a little bit about what's going on with this problem. Okay, in these problems where it says find the domain, that's a hint. That's a big hint that John is telling us there's something tricky about this problem, and some numbers that you put into this could cause a big problem. There are two primary problems that we're trying to prevent. You know, in all of mathematics that we've been studying, pretty much we can plug different values into anything and it'll all turn out fine. We have two scenarios that are deal breakers though, two problems that we've identified in the past that I know you understand, and we want to make sure that these problems don't crop up in this scenario. The first one is when we have a fraction with 0 in the denominator. We call this, whenever we have this, we say it's undefined. I have gone so far as to suggest that the world will implode, or at least the kingdom will blow up if we allow this to happen. It's just a deal breaker, right? We just can't allow it to happen. So the rule we've generalized from that is no 0 in the denominator. Right? That's the rule we've determined we need to create in order to protect these situations from happening. So we're never allowed to have zeros in the denominator because that's a problem. The other situation comes when we have a negative root. Now, that's okay if it's an odd number up here, right? If it's 3 or 5 or 7. But for an even numbered root, this is a big problem because we can't have a negative. There's no such thing as the root of a negative number unless you have it's an odd numbered root. But for an even numbered root, we can't have a negative in here. Now, we've developed a workaround. We've said, okay, let's say that we're going to say that's equal to x times -1. And then we're going to break them into their own little pig houses. And then we've developed this idea that says the square root of -1 is equal to I, right? That's an imaginary number. And we've contrived this workaround to deal with this situation, right? But this, so then we write it as square root of x times I. And that's the way we've learned to deal with the situation. But in order to do that, we've had to create what we call an imaginary number. And that takes us out beyond the realm of real numbers. So when we have something like this, we've learned to say no real number solution. That's the real way to resolve this. Again, we've broadened our scope to say, okay, well, let's say there's imaginary numbers and let's deal with it that way. That's fine, but the rule is that even numbered roots must have 0 or positive values only, okay? These have to be, it's okay for it to be 0 because the square root of 0 equals 0. That's fine. So it can be 0. It can be anything positive, but we can't have negative signs in there. So that's another rule we've developed to help prevent this situation, or really, you know, even if we don't want this situation, this is the rule we've developed. So when we're determining these domain questions, what we're really saying is, does one or the other of these rules apply to our situation? If so, how can we write a little precaution so that we never put those numbers in. So we look at this and we see, okay, this does have a denominator. So we have to make sure that we outlaw any values of x that would create a 0 down here. Okay, we're going to do that. Let's do that second. I want to do the first one first because it's a little bit easier. This rule also applies because we have a radical sign. Okay, so the two things you can look for is for this one, you look to see if there's a fraction. And for this one, you look to see if we're taking a root of anything. So we see, oh, well, this one we've got a double whammy, right? Because we do have a fraction, so we have to worry about that. But we also have a root in the numerator, so we have to worry about that as well. So we're going to deal with that scenario first. I'm going to put a 1 there. And this is my informational piece, so I'm going to kind of section that off. Now I'm going to go to number 1. What we know is that the inside of this, because it's even numbered, it has to be 0 or a positive value. So we can just write that in a sentence. The guts of that root have to be greater than or equal to 0. All right? I can build this simply from this rule. It has to be 0 or positive. So this expression has to be 0 or positive. Now I can simply solve this as an inequality. 2x has to be greater than or equal to -6, divide by 2, and I find that x has to be greater than or equal to -3. That will keep this from falling into this problem, right? Okay, so that's part of my answer, and I'm going to squiggle that so that I remember to come back to it. Now we're going to deal with this denominator. Oh wait, what we're saying is that 4x squared minus 4x minus 3 cannot be equal to 0. Okay. Well, I don't know what the x is. I'm trying to solve this for a value for x, right? And I see I've got a lead coefficient, so let's divide all of those away. And I get x squared minus x minus 3/4 cannot be equal to 0. Well, I'm getting closer, but what I really want is to be able to have something like that, right? Because then I can solve each of those binomials for a value. But I can't look at this and immediately say what's going to multiply to this and add to a -1. So what I'm going to do is and maybe you can, and you know, we all, in the right mood, the right frame of mind, most of us could do it, but you know, there's also those times when we can't. So I'm going to show you how we can push through the numbers to get an answer to this, even if we can't just magically see it. So what I'm going to do is I'm going to complete the square. I could use the man-eating dragon, but I feel like completing the square. And that's going to get me 2 values for x, and then I'll be able to fill this in and solve for what values of x would give me a problem. All right? So I'm trying to solve this. So I'm going to take that expression. I'm going to kick that to the curb. Oh, it's going to be plus 3/4 when I swing it across, right? So I'm completing the square, just like we always do. Magic number, this is a -1, so I divide it by 2 and I square it. I want that number. This becomes plus 1/4, plus 1/4. I'm liking the way that's turning out. Now I'm ready to write my square, and this will be equal to 1. And I know that this inside of here is what goes here. And I can double check. This should multiply by itself to that. Yes, positive 1/4. And it should add by itself to this. This is -1. So -1/2 plus -1/2 would be -1. Okay, so that checks out. I'm good. Take the square root of both sides. X minus 1/2 equals plus or minus, because I'm taking the root, but the square root of 1 is 1, okay? Then I add 1/2 to both sides, and I get x equals, okay, 1/2 plus 1 would be 3/2. 1/2 minus 1 would be -1/2. So now I can take this number, this information, and go up here. If x equals those things, then that tells me, this is how I can see it better. X minus 3 over 2, x plus 1 over 2. This cannot be allowed to happen, right? And so x cannot be allowed to equal 3/2, because then that would turn to 0. And x cannot equal -1/2 either, because then this would turn to 0. Either one of them would give me a 0 in my denominator and cause the world to implode and the kingdom would fall and it would be terrible. So that's another limitation I have to place on my answer. So in writing my final solution, I'm just checking the answer to see how John formatted. Okay. He said x is an element of the real numbers such that x, we'll do this part first, is greater than or equal to -3, and x is not equal to 3/2 or -1/2. Okay? Double checking. I just want to make sure that's 100% right. Yeah, it is. All right? So, this is pretty typical of these find the domain problems. Usually we have one or the other of these scenarios and we have to build protection around it so that we don't run into that problem. This problem was a double whammy because it had both. All right, I hope that helps. Let me know next time we talk if this is useful. Thank you.